Good morning, everyone. I'm Erica Sims, Co-Executive Director of Housing Forward Virginia. Thank you for being here. This is the second annual Housing xChat webinar that is showcasing innovations in the affordable housing industry, innovations that can drive change and scale and affordability in our work. We have the privilege of having a great panel here today to discuss 3D printers. Can they fill the gap in affordable housing? And with me today to moderate this panel is Chris Thompson, Director of Strategic Housing at Virginia Housing. He is one of the key people responsible for bringing 3D printing to Virginia and allowing Virginia to be on the cutting edge of this technology and experimenting with its use, in particular in affordable housing. And so I'm going to hand the moderating duties over to Chris for the remainder of the panel today. Chris?
Okay, good morning, and thank you, Erica, and also thank you, Flora, for both of your work to pull this together today. It's a really exciting panel, and I can say that, representing Virginia Housing, we are really thrilled to be kind of at the center of this new and creative, innovative technology, and just really want to thank our partners that are joining us today on our panel. I'm going to do just a quick introduction for each and then turn it over to our panelists to talk a little bit more about themselves, who they represent, and give us a little more background as to how we got to this point now. I can say on a personal level, it is really exciting too. I live not that far away from where the first home is going up in Richmond over on Carnation Street. And so I will sneak by and check on the progress once in a while. And it's been just really cool and fascinating to see this happen just right before our eyes. So again, Erica and Flora, thank you for the opportunity today. I think this is a great topic and comes at a very timely moment when we are looking at ways to create new opportunities to bring more workforce affordable housing inventory to the market. And so with that, I'm going to introduce our panelists. We're joined today by Zachary Mannheimer. Zachary helped found Atlas Community Studios, which is a team helping rural communities plan for growth. And Zach is also the CEO of Alquist 3D. We're also joined by Stephen Bastien. Stephen oversees all operational aspects of RMT Construction and Development Group's commercial and residential projects. And then we're also representing today Marion Cake with Project Homes, where he serves as the Vice President of Affordable Housing Development. So with that, Zach, I'm going to have you kick us off, and if you could share a little bit more about yourself and then just launch into your presentation, please.
Absolutely. Thank you, Chris. Thank you, Erica and Flora, for setting all this up. Thank you to Virginia Housing. We are really excited to share some data with you about 3D printing today. I'm going to lead you through a quick presentation about the work that we do and why we think this is relevant to solving particularly rural America's housing shortage, but what this can do for communities across Virginia and how we can help solve the housing issue that we have. So as Chris mentioned, I am the CEO at Atlas Community Studios. Atlas does creative placemaking to help with economic development and workforce development in small communities around the country. Today, we're working in about 20 different states. Average size for community for us is about 3,000 people. And the work is, how do we revitalize communities and set them up for further growth? How do we attract and retain new workforce to those communities? And how do we keep workforce in those communities that's there right now? We also work with Alquist. Alquist, we started last year, 3D printing company in construction. It largely was created because population and housing shortages have been real for decades. The perfect storm of economic, climate, and pandemic migration is happening right now across the country. So we have to be bold in how we respond to this right now. And this is really the driving principle behind everything we do with Alquist, is that every time a house goes up in price about $1,000, we displace over 150,000 American families. This is not a sustainable situation. We have to make a change. That's partially why this technology is so key. Alquist uses 3D technology to create exceptional design while lowering the cost of home building in economically distressed and underserved communities. Our focus is rural specifically because there's this myth about rural America that there's no good paying jobs in rural America, and we simply know that's false. That's not true at all. The reality is there's thousands of good paying jobs in rural America, but we need more people to take the jobs. And often those people are not there because there literally are not houses to live in. It also goes back to incentivizing companies. For decades, we've thrown dollars at companies to get them to move to a community to create lots of jobs. And there's nothing wrong with that. But today, it doesn't really matter how much money you offer to a community to move there. They're only going to come to your community if your downtown looks like this, if there's vibrancy, if there's a place where your workforce wants to live and a place where your workforce wants to move to. And so I want to share a couple ideas of where we see things moving in what we hope soon will be a post-COVID world. And we believe that rural America is the next place to innovate. And we believe that because of the migration patterns that are happening around the country that we've been following. For the past 40 to 50 years, the coasts of our country have been oversaturated and folks have been moving to communities inside. This is a map that illustrates that pattern pretty well. Over the past 50 years, you can see the rural population loss across the country. And in our congressional map, you see folks are leaving the Northeast and they're moving to the South and the West. That's great for you in Virginia, terrible for the folks up in the Northeast. And this is the trend that's been happening for about 20 years now. Here's a map of where they went between 2000 and 2007. They largely went to what we call second cities. That's places like Minneapolis, Kansas City, Nashville, Austin, Denver, Atlanta, New Orleans, Phoenix. Those are the cities that saw population gains on par per capita with a place like San Francisco 100 years ago, identical across the board. But today, we're in the rise of the third city. Richmond is squarely a third city. Richmond's a great example. Raleigh, North Carolina, Des Moines, Iowa, Boise, Idaho, Madison, Wisconsin, Little Rock, Arkansas, Birmingham, Alabama, Albuquerque, New Mexico, Eugene, Oregon. Those are the cities today that are seeing the population gains identical to a place like San Francisco 100 years ago per capita. And before COVID, we used to say these cities were going to hit saturation levels sometime around 2030 to 2035. But what we're seeing today is everything has changed. Largely that's due because of the housing trend. Housing bottomed out sometime around 2008, 2009, has never really recovered. In addition, lumber prices keep going up and they'll come back down a little bit, but they're never going to get back to what they were in pre-pandemic levels. So what we're seeing right now is when you're building a stick home right currently, you're looking at an average of $36,000 that you're adding onto the cost of the home simply because of the price of lumber. And coronavirus continues to make these changes across the board. And from migration patterns that we're seeing, everything has changed. Instead of people going from first cities to second cities and so on, people are going from New York to Clarksdale, Mississippi. This is the change that we're seeing across the board. Lots of people are on the move and a change is right now and it's very real. We see articles coming out all the time about people leaving larger cities. And really, when they're looking for where they're going to go, this is what we base all this on. It's that rural hierarchy of needs. Rural communities don't have the luxury of focusing on one of these issues at once. They have to tackle all these problems at the same time. But you can see the base is housing. Doesn't matter how great your schools are or how great your public utilities are or your quality of life if there's nowhere to live. You have to have housing at the base of all of this. We believe 15% of the American workforce, for what we're tracking right now, is on the move right now and will be settled by the end of 2023. That's 30 million Americans on the move. We need housing for them. The question is, where are they going to go? And they're more likely to go to the places that have the adequate housing that they're looking for. So 5 major findings that came out of this recent report at Harvard that are really relevant to this conversation. First of all, we know the inventory of homes for sale is at historical lows. Second of all, the home prices have been rising rapidly. We just surpassed $340,000 as an average home cost in America, which completely puts out most Americans. Rents are down sharply for high-end apartments in urban areas, which further supports the move of people leaving those areas and going to suburban and rural areas around the country. Renters and people of color fared the worst during the pandemic by far, and a growing number of people are experiencing unsheltered homelessness. So these are the issues that we're facing. And we believe one solution, not the solution, but one solution to that is 3D technology. This is what colors all of the scenarios that we're looking at right now and what drives us to do the work that we're doing, and especially the work that we want to do, continue to do in Virginia. So 3D printing is not new, using concrete. This was back in the early 1930s, scenarios where they had invented this machine to do 3D printing. It looks a lot like our machine right now, except there's clearly a lot more labor involved in this process. So they were doing this back in the day. This is nothing really new. Obviously, we've just seen advances in how this works today. So this right here is the first ever 3D printed building in Europe. This is in Copenhagen. It was printed by Cobod. This is the printer that did it, the printer that we have currently. And our first project was a collaboration with Virginia Housing, Virginia Tech, Project Homes, RMT Development Construction, everybody on this call, one big happy family trying to figure out how we're going to get this done. The goal was to create a 1,550 square foot, 3-bed, 2-bath, single family home slab on grade. And this is important that when you think about 3D technology and your mind conjures up how a robot's going to make a home. Your mind thinks about all these different shapes and sizes and curves and all these pieces like the Jetsons. And we can certainly do that. But for this first home and the first homes we're going to do in general, we wanted to do something that's much more approachable and something that fits the neighborhood on the south side of Richmond where the first home was being printed. We didn't want this to stick out. We wanted to be part of the fabric of the community. So the design speaks to that. This is what the home's going to look like when it's completed. Images of the interior here when you first walk into the living room, and then of the kitchen that's right attached to that. And you can see a video here of the print in action. So you saw in that video how it's moving. It has good movement, but the concrete that's coming out is at a much lower rate right against the line. And the way this works is you do BIM modeling using, excuse me, Revit software. That goes into the 3D printing simulation, the red and yellow that you see there. The red is tracking where the robot is printing, and the yellow is tracking where the robot is moving without printing. And this is called Slicer software that was developed by Cobod. That goes into the computer numerical control, which goes to the print nozzle and prints a house. It takes about 10 minutes. It's really, really easy. I'm joking. Much more challenging than that. This is also important, is that we didn't want to just do a home that's affordable up front. We wanted to create a home that's also affordable to operate and live in. And what we now know, thanks to our friends at Virginia Tech and the research that they did, is that because these homes are thermally broken, we know that we're going to be having an annual savings of roughly 50% of the utility cost versus a stick-built home of the same size. This is a really big movement forward. Obviously, we want to get down to net zero. That's going to require a solar panel and a battery. Those are not really affordable today for housing that's affordable, but hopefully one day we can get there. But this is a terrific first step in energy savings. Also, these homes can withstand tornadoes, hurricane strength up to Category 3, and they don't burn. All important categories as we look towards sustainability. Also, we're working with Virginia Tech to put Raspberry Pi technology inside every wall that we build. And this is really significant because this is still the bleeding edge of this technology. We want to track this data, see how these homes perform. So these sensors are going to send data back to Virginia Tech to study. It's also going to send data directly to the homeowner if they choose. These can work as the smoke alarm systems, the security alarm systems, but more importantly, it's tracking vibration sensors, humidity sensors, and moisture to see if something could go wrong in the walls. If something is detected, it'll alert the homeowner so they can take steps to prevent any real damage. Also, every home that we do will come with a personal 3D printer built into the kitchen, no different than a microwave. And we're doing this for several purposes, but what you see printing here is a light switch cover. And this is what we believe is the future of home renovation. And if something ever breaks in your home or you want to change the design, you're going to be able to go online, download a file, put it into your 3D printer and print it out yourself and repair it yourself. That's especially important for folks in rural areas when they're not driving an hour each way to a hardware store, or they're waiting 2 days for a screw to be shipped from Amazon. You can just print it yourself. And this is going to make a big change in the way we go and can help the movement further. Also, we had an unfortunate circumstance in Richmond. Overnight, one night, somebody broke into the job site and stole the print nozzles, which is kind of silly because you can't do anything with the print nozzles if you don't have a 3D printer. But we didn't let it get us set back. Instead, we broke out our 3D printers. We 3D printed a new nozzle for the 3D printer. And that we lost about an hour of time, and that ended up looking like this. And this is now going through a patent, which is really exciting. This print nozzle with the flaps that you see there allows us to smooth out the concrete further as we go. And I'll show you images of the second home here in a second that we use this on to see how the design has continued to change. So here's a shot of the home being finished in Richmond, the day that it was done, from the interior here. Here's a shot that I stole from my friend Steven on the call, where you see the slab here being placed right inside. And then this is of last week. The home has a roof. It's got framing in it. It looks fantastic. And we're really excited to see the direction that this home is going to go. We've received lots of great media with Virginia Housing and Virginia Tech across the board, which is really terrific. But it's really important that we focus on workforce development as a major piece of this, that there is no program nationally to train people on how to do this how to use this technology. So we're working with Virginia Tech to develop a curriculum that we can unveil next year. Anybody can take these courses, 6-week course in 3D concrete printing to get a certificate to do this work. We need a workforce created. We also need to be conscious of the fact that there needs to be a heck of a lot more jobs created from this workforce. And that's precisely what we're aiming to do. We're even starting at a super young age. I'm kidding, these are my kids, they're on the job site. They don't have jobs. So you can see here the differences between our first print and the second print. And this is really significant for the progression that we're being able to make. The first on the left is in Richmond, the second is in Williamsburg. We'll hear more about that from, I believe, Janet Green at Habitat for Humanity later. And this is, I want to stress this point, 3D concrete printing is still experimental. This is still the bleeding edge. There's a lot more we have to learn about this technology over the next couple of years to really drop the price across the board and make this more efficient. We're really at the beginning here, and I'm really thankful that Virginia is seeing the future and able to jump into this in a bold way. So our next steps are to test out different materials, different speeds, different temperatures, different structures that we can make. We're also partnering with a group called One Vision, where we want to be able to create a hempcrete. This is, we're using a mill processing facility that takes the hemp plant and breaks it down into a raw material so that we can make a hempcrete and use that for a variety of things across the board that we can build. And finally, we're going to be working with Black Buffalo, which is a local to America 3D printer in New Jersey. Our services across the board are different things that we can do in terms of consulting or actually straight up printing. And I want to remind everybody, we go back to this rural hierarchy of needs. This is what it's all about. We have to fix these issues here. 30 million Americans are on the move. We need to address this problem right now. 3D technology is one way to do that. We believe rural America is the next place to innovate. And I want to close here with this quote from Richard Florida, who's a great mentor of mine, that really sums up the issue very well. The remote work revolution promises to change the way that Americans work and live. It will allow smaller cities, suburbs, and rural areas to compete with the superstar cities on the basis of price and amenities. It will shift the main thrust of economic development from paying incentives to big employers to investing and building up a community's quality of life. As communities attract more remote workers, their tax bases will grow, allowing them to improve schools and public services, benefiting everyone. Eventually, companies will come too. That holds out the possibility of a better, virtuous circle of economic development. I could not agree more. And I'll show you a couple images here of the second home that we did in Williamsburg. You can see the speeds are faster. We have our flap system that we developed on the print head there. We're able to cut and smooth the concrete as we go. It's a big game changer for us, only from home 1 to home 2. And you can see here the difference that it makes in the look and feel of the home itself. Really excited and proud of this, and very, very thankful for the work that Virginia Housing, Virginia Tech, and just the state in general has decided to do for 3D printing. So thank you so much, and I'll turn it back over to Chris.
Thank you, Zach. And wow, it's really exciting to hear, this is not just about housing, but as you said, this is community development. It's touching all aspects. And I really like how you also bring in the workforce component, because you're right, there's not a training program for this type of technology. And so, thinking about that and how that offers great opportunities in our rural communities is fabulous. So appreciate that. I'm going to now turn it over to Stephen. Stephen's going to talk to us a little bit more about how the technology works. And so with that, let me hand it off to you, Stephen.
All right, sounds good. I am going to be primarily focusing on some of the technical aspects of the building, specifically how we kind of tie in some of this new technology to some of the older technology. One of the things that anytime we bring new technology into a construction industry is we see hesitation from existing contractors. By approaching it the way that we did with the first house, we're still able to incorporate a lot of different trades that's involved in the house to be able to bring comfort to the entire industry, which is allowing the industry to be more accepting of the technology. Once they get their hands on it, then they can start to push and expand the envelope just the same. I did want to share my screen. We can do a little PowerPoint. Apologize, I think I should. All right. Bear with me, I apologize. We'll just kind of go from the screen. I have 3 screens set up and they're all disoriented a little bit. So primarily, like I said, we were looking at the 3D printing housing technology and how it's adapted. The printer itself, it's simple yet complex adaptation to what we think of when we hear 3D printing. Just as in Zach's presentation, he showed the desktop 3D printers that when we say 3D printer, that's probably the first visual we get in our mind. That same technology is used, the same basic theories and technologies behind it, but it gets immensely more complicated when we introduce the concrete itself into it. So it keeps the same rough structural design as you can see in the photo. It's an overall gantry crane. It has 4 posts, and there are different printer technologies that have come up with some basic 3 different designs. This is by far the most popular. It's what we've seen around the world and produced the most. Again, it runs on similar principles and theories, but the complexity starts at the printer head. The printer head has to agitate the concrete itself at a certain rate to be able to extrude it. So there are actually 2 different controls. We have a pump that's offsite that pumps the concrete into the 3D printer, and that 3D printer head has an additional extruding pump that allows it to extrude from there. Again, tying concrete into this is where we start to get complicated. Asking the concrete to do some of the things that we need it to do requires a lot of technology in the concrete solutions itself with completely different new mixes. That's one thing that we were able to accomplish when we were on site is we worked with SpecMix and Quikrete to come up with a couple different iterations of some 3D mixes. This is going to help, again, foster that industry to allow other partners to be able to take advantage of some of the work that has been taking place at the Carnation Street. So shifting over from the printer into some of the engineering features and how we've tied things together. We've introduced typical foundation styles that we would see with any CMU or foundation wall, and we incorporated the 3D printing that way. We decided to go with that general direction for a number of reasons. Again, existing construction technology, things that are already in common use, things that we already have information and technology and data on it, and we use the 3D to adapt into current models. This allowed us to study the 3D printing itself and really narrow that down to what we need to do on advancing that forward while not having to focus quite as much on reinventing the entire wheel, but yet adapting it too. Energy considerations, as Zach talked about, are also one of the most important parts of this project. And it's actually what really brought me into the project was the different thought process of how we look at affordable housing, and not only just what it's cheaper for the initial buy, cheaper for the contractor to build. Those things are obviously very important, but it was also very important that it was an affordable housing to live in. And that's where those energy considerations come in. The unique design that we're seeing here in this detail is realistically showing a fully isolated slab. So we have 2-inch rigid foam insulation that completely encompasses 3 sides of the concrete slab. This allows no concrete to be touching the ground, which would allow for thermal expansion, thermal radiation to come into the house, making that floor cold. We all know when we step on a concrete floor barefooted, it's a very cold floor. This concrete floor is going to absorb most of its thermal natures from the actual atmosphere inside the house. So after the first several days or weeks of the HVAC system being on, that slab is going to maintain room temperature to where it'll be warm to the touch. That drastically decreases costs of actual living and maintaining the house. Some of the other energy considerations were in the HVAC system. The HVAC system, we were able to use a smaller unit within the existing structure. Some of the reasons that allow us to do that was because of the thermally isolated slab, and also the 3D printing technology allows us to insulate the walls at a very high rate. We're looking at somewhere in the neighborhood of 22 to 26 R value currently, and that's going to change depending on insulation type. There are a few different insulation types that are acceptable here. Availability and the current market conditions what may sway a decision one way or the other based on availability by region. But this extreme insulation type allows us to treat this house like a Yeti cooler. By having that extreme insulation, and we could really reduce the operational cost of the HVAC unit. We also, the location of the HVAC unit is important as well, by making sure that the air handler itself was placed in a heated and cooled space. It allows that HVAC unit to actually run significantly more efficient than it otherwise would be placed in the attic. So all of these energy considerations allow it to have that affordable cost model passed down to the owner beyond the initial purchase. It's going to allow them to maintain that affordable living. And the last thing that we have is just a quick video that kind of shows start to finish of our carnation project that we can take a quick look at. And I do realize that I'm glancing over a lot of these issues, and I expect to have a lot of questions at the end. I appreciate everybody's time for viewing. Thank you so much. I'll turn it back over.
Stephen, thank you. And I know you've made a comment about learning or having the concrete do things you're not normally accustomed to. And I would also just comment that all this was happening at probably the hottest point of the year in Richmond. I know on the job site, it was triple digit some days, and also you're trying to factor in the humidity. So certainly a lot of R&D going on when you were experimenting with this. So a lot of good lessons coming out of it.
Absolutely.
And going to pass this over to Marion Cake now, and Marion with Project Homes is going to talk some about how this type of technology fits into affordable housing, workforce housing production. So Marion, have at it.
Thanks, Chris. I'm going to share screen with you all here. And I'm just going to kind of give you guys an idea of how this innovation work ends up affecting those of us on the ground producing houses, how it's played out just in our experience. I'm Marion Cake. I'm the Vice President of Affordable Housing Development at Project Homes. Project Homes is a nonprofit specializing in the preservation and production of affordable housing in Central Virginia. We're focused on single-family homeownership opportunities in Richmond and the surrounding counties. And we've built about 250 affordable homes and are getting ready to celebrate our 30-year anniversary. So I'll talk a little bit about our journey so far with innovation, including the 3D printed house. So in the 30 years, a lot has changed. And our focus has shifted as the needs have shifted. We've shifted away from revitalization and more towards affordability. And our challenge has really become balancing the art of building a high quality home that provides an opportunity for generational wealth building, brings lasting value and change to a neighborhood, but at the same time is sustainable and can be done affordably and at scale. We and many others can build the highest quality energy efficient homes in Virginia, but we need to build a lot more of them, a lot faster, and a lot cheaper with minimal subsidy, all the things that the municipalities and the politicians love to hear. Easy, right? No problem. How do we do it? So we started looking, as conditions changed, we started looking at things that we know. And what we're good at is construction. So we really focused on innovation of the housing production itself. I think there's pieces to this. There's different innovations we need in housing finance and marketing, all of that. But we know construction, so that's what we focused at. And it's all about innovation. We started just with what we know. Going from larger houses to increasing density with narrower attached homes. And we found that if we really focused on attached pairs, which often you're allowed to do within an existing zoning. And what we found was we could get down to 14, 13, even 12 feet wide houses if we did attached pairs, because light, space perception in a room has a lot to do with the light that's in a room. And you can really make a house feel larger by providing enough light in the right place. So we went with bigger windows on the three sides of the attached house. Tried to stay away from long strips of townhouses. And we got down to 14 feet and then 13 feet and then 12 feet. And we even did an 11-foot wide detached house. And then my project managers asked me to please never go any lower than that. So we backed off. But what we found was it's a lot about design. It's a lot about light, little things like raise the windows up so that you have more room for furniture while you're still bringing in light. The first one we did looked really good till we brought a couch in, and then the house, shrunk by half. So it's really important to think about not only what you're building, but how the people are going to use it and how it's going to feel once they buy it. We also started to really focus on energy efficiency as a way to keep costs down. We've been building very tight energy efficient homes for 20 years. And we kind of got to the point where we couldn't really make them any tighter. We were kind of getting diminishing returns from just air sealing and insulation. So we started shifting towards on-site power generation with, in this case, for these homes, it was photovoltaic solar cells, net metering systems, just to get at least the electric bill on. So that was fun. We next started to focus on the process of how we actually build the homes, trying to get some economy there. We use a project manager system instead of using a GC, and we started doing that years ago in an effort to just have more control over the finishes and quality of the product. But what it really taught us was what we really needed control over was the process, the scheduling, how stuff flows in and out, how quickly you can get. Even with a traditionally built house, you can save a lot of money and time that way. We were losing a lot of time with scheduling. So with the project manager system, we have one project manager responsible for every hour of labor and every piece of material that goes in the house. It really allows you to fine tune the process and the workflow. We experimented with building some panels, some panelizing processes. This is from a blitz build that we did where we built a house in 5 days, which, in case just really trying to streamline that process. In case you're wondering, that is not the least expensive way to build a house. The panels kind of led us to a modular experiment. We built some modular home construction in Henrico and Chesterfield using existing modular manufacturers with some tweaks to get it to where we wanted it as far as finishes. We learned a few things. The quality of these homes is good. They're put together almost as well as anything that we could build on site. The bigger the box, the more expensive it is to move. Duh, you think we'd have known that, but it took us 3 or 4 of them to really come to that conclusion. Overhead power lines, site conditions, they really limit the feasibility of this kind of construction. And these homes end up costing, in our experience, about 10% less than a site-built house, which is probably why they haven't taken over the market. You're still kind of got that general contractor thing where you're hiring this manufacturer to build most of the house, and they're only going to give up so much of the savings that they get from building these things in the factory. We also got an opportunity to build a house made out of shipping containers through a partnership with Virginia Housing, which is where most of our our innovation comes from. And we're really excited to be able to try this. These boxes were significantly easier to move around because they're made out of shipping containers, which are designed to be moved. But they also had some limitations. Their design's limited by the size of these things, the structure of these things, and also shipping containers, just little things that we never thought of. Shipping containers are designed to sit on 4 points. And so the point loads on this foundation had to be ready to accommodate all the way to these homes. And that added to a lot of cost of the foundation. So that was an interesting learning experience. But we had a real good time doing this. These shipping container homes are incredibly strong. I think there's real potential in high wind areas or disaster housing. So I'm going to watch this space and see where those go. So the bigger the box, the harder it is to move. But what if you don't have to pick it up? That led us to our latest innovation, where we are working to develop a sustainable quality product for manufactured housing. We've designed and installed several replacement manufactured homes that are built more like homes, so they would last more like homes, hold their value, and really change the perception and the quality of life for folks living in manufactured homes. The idea being, if it's built more like a regular house, it will last more like a regular house and behave more like a regular house. These things have to be built to meet a HUD standard, which makes them legal to put in existing parks, which means you have to buy them from a manufacturer. So we still kind of end up with that little bit of tension there where we don't have control over all of the aspects of the way the house is built, and we don't have control over when we get it or the cost of it. So for our next trick, we are going to build our own manufactured homes in our own little factory, just in an effort to control that process and see if we can take the product to another level. So this is our latest innovation. We've been partnering with Virginia Housing and Virginia Tech. And our hope is that this will lead us and take it to another level. We're going to put these units in a mobile home park that we purchased in Chesterfield County, and slowly replace the pretty dilapidated units for each resident in that park. Our general lesson with all of this innovation is that it's essential. It's the only way that we're going to be able to go into the future. Every innovation ends up fighting a pre-existing established process, and you have to sort of power through that. But it's our belief that we learn something from every new innovation that we try, and it changes the way we do things. And we're really excited that the 3D concrete house has already taught us a ton, and I think it could be a really important tool in our next round of houses as we come out into the next market condition. Happy to answer questions later. Thanks, Chris.
Thank you, Marion. And as you can see, Project Homes does some amazing work across a spectrum of different housing types. And we do joke sometimes that we're afraid that Marion and Lee and team will start blocking our calls because we often use them as a sounding board for some of our more interesting ideas. But as you can see, they just do some fantastic work, and we're happy to have you all as part of this project as well. I should mention, we do have lots of time for discussion and questions. We're asking folks to please use the Q&A tool at the bottom so we can have that open to be able to moderate our questions. Sometime a little bit later, we will have the Habitat for Humanity CEO for the second house that's being built on. So we'll turn over the discussion to her shortly. But as we move into our time for Q&A and discussion, I did want to just kind of start with an initial question, and don't know if this is best for you, Marion or Stephen, but saw in some of the opening videos, we saw some elected officials. We saw the mayor, we saw the councilman, and just wondering, what the city's reaction has been to this new type of technology, and also just from the building code side, has there been any enhanced, I guess, scrutiny of this? So anything you can share on those lines?
Yes, absolutely. Enhanced scrutiny, yes. I think that when we're done with this project, it'll be one of the most studied houses in America. So the scrutiny level is to commercial standards is basically what we've been following through what we would normally take with special inspection processes that would follow through the commercial building code. We kind of adapted because of our use in concrete and the sampling that we really needed to be done. We took core samples, we've done compressive strength tests through every step of the way, every pour that we had, and that was again in part to confirm what Quikrete was designing as their product. As far as inspection process with the city has been very accommodating. They have pushed through. They were able to speed processes up that we needed to in certain periods of time. They've been very interested in the process. They've been out on the site, even people that aren't involved, because this kind of excites us all. Any of us that are in this industry, this is exciting. We all want to see it. We want to put our hands on it, and so that's kind of the response that we've been getting. It's been great. We get a lot of positive feedback. Everybody wants to make this happen. We're all here with the same goal and aim, and that's to have affordable housing and grow this new technology that will be able to aid in that.
Thank you, Stephen. And Marion, anything to add about your interactions with kind of the local officials?
Very, very supportive and positive. I think everybody understands the need that we can't just keep doing things the way we're doing it. We have to try new things. They were excited to have it in the city and supportive of the work.
Great. I see there's a question that Zach has taken opportunity to answer, but I'll go ahead and put it out there so everyone can hear it and also maybe expand on it some. So there was the question about how long it could take before 3D printing is becoming more mainstream in Virginia. And so the response from Zach is conservatively, 24 months, but we're all hoping for sooner than that. But Zach, if I could just expand on that. So you're working on 2 homes right now. And from what I understand, you've already had some learning opportunities moving just from one site to the other. So anything you can share about, either some challenges and how you've overcome those, or, some lessons learned that you've already been able to apply as you've moved to that second site?
Absolutely. Tons of learning curves in this process from house one to house two. The biggest variable we had for both homes and will continue to have is weather, and it's heat. And something that affected us on both homes is once it hit, and Chris touched upon this earlier, like once it hit around 90 degrees outside, the material tended to fall apart, and we'd have to stop printing for the day. So we ended up starting super early in the morning, trying to go as long as we could till that heat became a major factor. Going forward, we were able to get past that a little bit on the Williamsburg print by talking to our friends called Perry. They've been printing in the Arizona desert. And they basically said, look, you got to print faster. And we weren't expecting that. And so that's what we tried on the second print. And that did significantly help the process. We were limited on how fast we can go to the OSHA standards. So we're going at our top speed right now, which is about 250 millimeters per second. Perry's going at about 300, and that's where we want to get to, but that's going to require some changes in code. So we're working on that. Also, the material that we use, Quikrete, they were great, super helpful. We couldn't have done this without them. There's other materials that we want to test. And so that's why we're going into a warehouse now for the next couple of months, and we're going to begin prototyping until the springtime when we're going to be out and printing again.
Great. So I see you had started to answer one of our next questions, but I think that this is probably something that everyone's going to ask is just about cost, target cost, expected cost. And I guess I would just kind of preface this in saying that, when we, started on this journey together, this is a pilot. And so you're basically opening the box, the printer, and starting with, the understanding that there's going to be a lot of experimentation, R&D, and practice necessary. And so I think the intent is going to be looking at certainly all the costs necessary to make this happen, including the investment in the equipment, but also looking at how you segment that out into the R&D costs and then the actual true cost to build. So with all that said, anything to share, although it's still in progress, about costs or any surprises on that front?
Yeah, and what you just said is absolutely right, Chris. And we're going to have all the costs done in the next month or so when the homes are complete. But I can say there is a slight cost savings between 3D and stick-built homes, apples to apples, in a direct build. It's not dramatic just yet, that cost savings. What we've learned, a couple things. Number one, we know the cost savings can be dramatic if we're printing 10 or 20 more units at a time. Spreading the cost out of setting up the printer, moving the printer, all those pieces across several homes, that is going to drop the cost. We know that. As the printing technology gets faster and the materials get stronger, we know that cost will come down. We did have a significant savings between house one and house two because we got better at it and we're continuing to get better at it. So that's why conservatively, I would say 24 months before we really are able to drop those costs dramatically. We believe it is coming. It's already happened in other parts of the world, not yet here in America. So, and we're not the only group doing it. We're in contact with several other companies around the world who are working on this, and we're sharing best practices. So we are going to get there. Another thought is we believe there could be a cost savings by taking some of the ideas that Marion was sharing in terms of modular housing, of 3D printing prefabricated interior wall systems. If we do that in a warehouse, move them out less than 20 miles away, and then we are also bringing the printer out to print the exterior frame of the home, combining those two technologies. It's too early to tell. We don't know if this is a solution, but we think it could be, and we're looking forward to combining those two efforts to check it out.
Thank you, Zach. So Marion, you obviously talked about the great experience you have in working with both rehab and new construction. And looking at this project, can you tell us kind of what the plans are, what your role is going to be when the home is finished, and thinking about the ultimate, immediate plans for it as well as the disposition?
Sure. This house is, we're working with Better Housing Coalition to sell this house to an 80% area median income buyer, which is typically where we've been focusing our affordable housing. And it comes down to, we get stuck in that 60 to 80% AMI buyer bracket. And we want to see if this model helps us get there easier in the long run. but that's really where our focus has always been, right in that niche. So it'll be marketed as soon as it's done.
And then I'm not sure if everyone is familiar, but this is just a block, basically a block away from where your headquarters is. So it's very convenient access. And I believe we also hope to have it open for a little bit of time before it's ultimately sold, so that we can host some educational tours and help to build awareness around it. So hopefully there will be an opportunity for those who are interested to come take a look at the final product. And speaking of final product, and maybe this is going back to you, Zach, but can you talk a little bit about when interested parties will be able to see this technology on display, either building more homes or just for demonstration purposes? I know you've got a couple of potential venues lined up down the road.
Yeah, we're looking, we really want to commercialize this and normalize this process in America. And that means we need to be transparent with everything that we're doing, with other builds that we're going to be working on. So really pushing this, and the best way to do that is to get it seen by the community. So we're hoping that we're going to be able to get a warehouse facility in the Richmond area to put our printer in that we have currently. We're going to be getting other printers as well. But we want to, inside this warehouse, we want to have a couple days every month that are open to the public, where we're printing. Folks can come in, see it, ask questions, touch it, feel it. We know that's the best way for people to get comfortable with it, give us ideas on designs. Obviously, they can come in other times by appointment, but we really want to open this process up so folks can get a better understanding of how this works. We see this as a massive industry across the country that's going to create tons of jobs. And as Chris was saying earlier, really help with community development. That's the ultimate goal. So the more people that can help us with that process, the better. So we're hoping that we can do that here this fall.
And it's if I'm correct, there are plans to have a display of some sort at the upcoming Governor's Housing Conference, which is in November, and then also working with the team here with Housing X for the next event, which is going to be in May, I believe. So I think there are plans to have a demonstration there as well, correct?
That is correct. We would love to do that. And we're also experimenting with the interiors. Our goal is in 2 years, we want to be able to 3D print every aspect of a home, including everything inside, out of other materials than just concrete. But we're already experimenting in printing food. We're printing clothing. We're printing furniture, printing doorknobs, drawer pulls, all sorts of things. You can print anything. And we still don't know yet what the best materials are for many things and how that's all going to work, but it's a brave new world. We're really excited about it. So more chances we get to demonstrate it and bring it to Virginia, we're gonna take those opportunities.
Great. Stephen, good question for you. Can you share some about what the staff at RMT, kind of what their reaction has been to kind of working with this new technology, and also what kind of challenges have you run into, since that's a lot of this is experimental?
Yeah, primarily a lot of the challenges that we run into are of the experimental nature. This being the first house, there are a lot of additional processes that are involved that won't be moving forward because we're going above and beyond to make sure that it's studied, that we understand the technology, as we move forward and develop a base guideline of how things, should be done moving forward. So that's probably the biggest, lots of little changes that happen anytime that you're in an experiment. Things kind of will have to change on the fly. You have to be adaptive to change. And in a construction industry, we're adaptive to change. But on an experimental level, it's just a new degree of it. That and the heat. The heat was probably the biggest factor by far.
Yeah, I remember there were a couple of representatives from Kobod who came over from Denmark, and I think the humidity was a bit of a shock for them as well.
Yes, it definitely was.
Absolutely was.
It's so often something you don't expect, something little. Who'd have thought of that?
Right.
Well, it's crazy though. The humidity is good for the concrete. The moisture in the air is good for it. It's the heat that kills it.
Yeah.
Question from Helen McElvain up in Alexandria, which is a good one. So can a printed home have exterior finishes that kind of reflect community aesthetics, like brick facade, or what are the options or opportunities around the exterior?
That's a great question. It's one that we're messing around with right now. So we're Eamon Hussein is our lead printer operator. He lives down in Williamsburg, and he is the one who's doing the polymer printing. He's got several different print nozzles and print flaps that can do different designs for the homes that we're going to be testing out. There's also a company out of Columbus, Ohio, who has a wall system that can bond onto concrete and create the look of brick or wood or siding. We don't yet know how well that's going to work or what the costs are around that. We're going to be working with them in November to test that. So we're hoping that can be, it's basically imprinting onto the concrete that look and feel. So we think that's coming. I wouldn't say it's ready just yet.
Great. Another question, just kind of looking to the future. Both of the homes now are single family detached. But what are some other opportunities to do either duplex, quads, or even start going more vertical?
We would like to go above 1 story. Nobody's printed above 1 story in America just yet. They've done it in other parts of the world. Not too many examples just yet, so it's really early for a lot of this. But next year, we're hoping we could do at least 2 stories of a quad system, possibly 3. The Black Buffalo printer for the company out of New York and New Jersey, they have a printer that goes up 4 stories. It's a monster. It's very impressive. We're testing out the pros and cons between that one and the Cobod unit we currently have. So there's other printers that will come online, but I would say definitely by 2023, there will be multi-story structures printed, hopefully next year.
Wow, that would be awesome to see.
Yeah, multifamily will drop the cost.
Yeah, I would imagine if you can do more at scale in terms of number or just density, it's going to help. So Marion, I think this one's best for you, and we're going to go back to your discussion around manufactured housing. So can you talk a little bit about the ownership structure at Bermuda Estates? Just who owns the land, who owns the homes, just what that model looks like.
Yeah, so right now Project Homes owns the park. So we maintain ownership of the land, and then the residents own their units. And we've been working for ways for them to purchase the new units as they're replaced. Success is all the park residents stay where they are, and those that want to are able to buy these new, longer lasting, higher quality units.
Great.
It's been part of the key here is it's an interesting world of manufactured housing when it comes to the certification of these units. They're not built to the building code, they're built to the HUD certification standard. And HUD doesn't certify a unit, they certify a process. So they certify how the units are built. But we felt it was important to go ahead and build these replacement units as HUD certified units so that they would be legal to put in any park, not just ours. We can't buy every park and rezone it. So our thought is let's build something that could be used anywhere in the state or the country.
And your mission is, correct me if I'm wrong, but I mean, really is to revitalize that park. So it's the housing, it's the other amenities in the community. And also just focusing on non-displacement. I mean, just trying to
Exactly.
keep everyone who's there now in place.
Yep.
Great. I'm not sure if Stephen or Zach or maybe both of you want to address this question, but the topic of heat has come up, and what happens with the concrete and the consistency. So can you talk a little bit about how the heat affects or impacts the printing, and does it also have a more longer term impact in terms of sustainability, cracking, or deterioration?
Primarily, we're under the same constraints as any other traditional concrete pour. We don't have any additional constraints put on us. So the same issues that we would have with pouring in heat or cold, we were going to have the same issues with printing in heat or cold. It's primarily a consistency issue. There are certain accelerators that are in these mixes, and it's designed for this mix to, from the time that it's mixed at the pump to the time that it comes out of the nozzle, is a specific period of time. As the heat builds up, that those accelerators work a lot better in the mix, and they start to harden the mix a little bit earlier. And in some cases, it could actually make it a little bit more liquid too, depending on the certain scenario. So it's just, once we start to hit a certain heat rating, we're just dealing with inconsistencies. And on the aesthetics level, it just doesn't look very good. Now, there are certain temperatures that are extremely high that do start to affect the strength of the material, but not what we're dealing with on job sites. Usually by the time you hit 90 degrees, it's unworkable. So realistically, when you're starting to get into strength degradation with heat, you're significantly higher than that.
Zach, was there anything you wanted to add? I know you've also been looking at, down the road ways to do some cooling or maybe even tinting around the job site to help control, some of those environmental factors.
Oh, I thought we nailed it on the first print where we bought a window air conditioner and duct taped it to the water line to cool it down. I mean, that was pretty brilliant. We did do that, by the way. There's still a lot more to learn, but I think something we've looked into is a tenting system that has a misting system. Something you may have seen in some of the videos. You may have seen humans walking around with backpacks full of water, spraying down the concrete as we printed, which was necessary with this material, may not be necessary with other materials. That's what we have to test. But we think if we can tent it with simple plastic around the print, around the whole operation, and set up a misting system, misting rods in the ground, pretty simple. We think we can try and maintain a temperature, which will make printing a lot easier. The setup and breakdown, of course, of that has a cost and a time factor with labor. But we think that'll be a lower cost versus the amount of time that we'll lose printing once the temperatures hit what they hit. Of course, we could say, hey, we're not going to print in the summer, but that's not really practical. So there's a lot of pieces that we're looking into right now. But the most 3D printed structures in the world right now are in Saudi Arabia, in the middle of the desert, where it's even hotter and not as humid as where we are in Virginia. So it can be done with the heat. We know that, but they're using different materials, but the materials they're using are more expensive than some of the materials that we used. So we're trying to weigh all that. They're not building these structures in the Middle East for affordability purposes. They're building them to build them and to use the technology to create new and intriguing designs. We're using it for affordability. So that adds a whole new layer that we have to look into. So I think the jury's still out on the best process.
Just a follow up to that. I remember one quote, I think it was Andrew McCoy, who said, it's kind of like building a cake, just layer after layer. Can you talk a little bit about like how many layers were necessary to get the wall system up to the height you needed, and also, ideal situation, how long each pass takes, because it seems like the concrete cures pretty quickly before you keep making the passes to build up and go vertical.
Yeah, I mean, the concrete does cure quickly, which is good and bad, because if it was curing too quickly on the first home, we were not able to slice the exterior concrete off to make that smooth wall. We were able to get that changed for the second home. But all in all, the 164 layers for the Richmond home. And the average layer time was about 8 minutes to make a single layer pass. Now we got that down to close to 7 minutes in Williamsburg. Total print hours for the first home in Richmond was about 28, 29 hours. For the Williamsburg home, it was about 21, 22 hours. So we were able to shave off a good amount. Our goal for a 1,500 square foot home is to try to hit about 17 to 18 hours of print time. That's what we're shooting for. Hopefully we'll get there in 22.
It's pretty impressive to think going around the entire perimeter in 7 or 8 minutes and having the concrete be able to bear the load for the next layer.
It's very cool.
Yeah. Marion, I think this is for you. I'm going to kind of combine a couple of questions back to your manufactured housing. So part A, how do the homeowners recapture their initial investment made on the old mobile home unit? And the second part is, are the homes that you're bringing in now, are they on axles?
So yes, they are. And that is part of the building them to meet the HUD standard, which allows them to legally be placed in the park. So yeah, they are on axles. We're putting these things on conditioned crawl spaces once they arrive. Our finding has been that these homes rot from the ground up. The water hits the roof, runs down the side of the house, gets under the thing, and the moisture just builds up underneath these old mobile homes. So we've eliminated that with eaves, gutters, water management, and then also the conditioned crawl space under the house, which has made them about 45% more efficient than just the standard. And when we bought the park, everybody in the park owned their house, and so I don't really know how much they've spent on these things, but what we have strived to do is to keep the cost of these first few replacement units equal to what they would end up paying for a used unit if they were to try to bring one in the park. So they're heavily subsidized for the first go round. As the park stabilizes and values adjust, I think there's probably some room to maneuver on that. But right now, the bottom line is we want to keep their house payment to about $250 a month. So they pay for that, plus their lot rent, keeps the total cost, at $700 or $800. And that really allows us to serve the 40 to 50%ers that we hadn't been able to serve with the other homes.
And I would say something that I've heard from you and from others at Project Homes that's very impactful is you're trying to change perceptions, because when people think about manufactured housing or trailers or mobile homes, whatever, I think a certain image comes to mind, and you're trying to do a lot to change that perception. And something that's kind of stuck with me was you're trying to build a product that doesn't lose value, but at least maintains, if not, has the ability to increase. Is that kind of a fair statement?
Yeah, and a big part of that is certainly the perception of it, but also just how it's put together. I mean, people ask me how long these things will last, and they should last as long as any house, because they're built like any house with materials that you'd get from Home Depot or Lowe's. The idea being they need to be easy to maintain. And one of the challenges with manufactured homes in the past of all types is, they use some door that they bought somewhere that you can't get anywhere else. It's proprietary, and it makes it very difficult to maintain and replace these things. So standardized parts, built as much like a house as possible.
Thank you. Zach, I think this is for you, and kind of goes to some of your broader mission work. The question is, mentioned earlier with the pilot project, is trying to build generational wealth. So how is marketability, the acceptance of the home for the market, for purchase and lending purposes being addressed?
Oh, that's a great question. And generational wealth is something that we're dealing with all the time, that there's no better way to do it than home ownership, in my opinion. I would say we're really early on the marketability and general acceptance of these homes. However, I think in 2 months, that's all going to shift when people see the 2 finished homes, and they can, just going down there last week, having not been there for 2 or 3 weeks, the changes are dramatic. Stephen and his team have done an amazing job making this look great. And I think when they actually can see the home, it's hard to visualize what these look like. And many of the 3D homes printed worldwide have interesting shapes and curves and so forth. And that's not really what folks are looking for, not today, at least. So these homes were meant to look traditional, and I think they will when they're complete. So that, I think, will begin to shift this. And really, it's like any other product. The more of these that come online, the faster they'll get adopted. Our hope is that by 2023, this is a fairly normalized process. Our prediction is by 2025, most construction companies will have a printer of some sort, whether a big gantry like we have or a small robotic arm. It's not going to replace all the work, of course, but it'll complement what folks are doing on the job site today. In addition, I think most academic institutions, especially what I'm hoping for our community colleges and trade schools, will have machines in their centers for training purposes. So this will become normalized, we believe. The way I got into this was 6 years ago. I went to a lecture by a futurist, which I don't really know how you get to be called a futurist other than calling yourself that. So that's interesting. But he was a futurist. I went to the talk and he was talking about all these different things. And one of the things was 3D printing concrete. And there was a gentleman in the audience who asked a question, said, hey, this is back in 2016. They're like, how soon until this process becomes normalized? And he said, well, with the issues of zoning and codes and all sorts of things in urban areas, it's probably going to be another 10 to 15 years before it's normal, which I think he's probably right. But afterwards, I went up to him and I bought his book, so he talked to me. And I asked him, said, hey, I think you're right about urban, but in rural areas where there are very little restrictions and barriers to entry with this type of work, don't you think that this could be adopted faster there? And he thought about it and he said, I had never really considered that. I think you might be right. And that's all I needed to hear. That set me off on my journey to learn as much as I could about this. And so far that has held up. So I would expect by 2025, this to be a fairly common process across the country. And by 2030, it'd be very, very normal.
And just as a follow-up, maybe this is something you and Stephen can both address, but in the photos that we've shown so far, we haven't shown the inside, which has more of the traditional framing. And I think for the home on Carnation Street, you plan to have some exposed concrete in part of the house as well as drywall in the others. And I'm thinking this gets back into marketability and just kind of consumer expectations. So can you just talk a little bit about, again, opportunities to, do something that even though you're using 3D technology, you still have something that it's, consumers are going to see and think, yeah, this is a place I can call home?
Absolutely. In fact, I will share my screen here for a moment. I didn't include this slide because I was worried about time, but I shot this video here last week. And this is walking through the home itself.
And all of the walls that are being shown right now are going to be the exposed ones, the ones that are in that big room, the open area, which is going to be the kitchen and living room.
So you can see that it really looks like a traditional home when you see the framing that's in. And many other 3D homes will have the interior walls 3D printed. We didn't want to bite off more than we could chew on this first one, so we went with this route. But it's going to look like any other home. And Stephen's right. What he was saying there is that some of the bedrooms we're going to frame up with drywall over some of that to help with acoustics. But the kitchen and living room area, we're going to leave exposed. And then this look is a nice look. We think the look that we got in Williamsburg is even better with being able to smooth it. And we think we'll continue to improve.
Stephen, anything you can comment on in terms of just how you're handling placement of things like the electrical conduit or plumbing and anything different you have to consider for this, versus your more traditional builds?
Yeah, it has to be thought out well. As far as plumbing, all our plumbing is under our slabs and come up in interior walls, just like you would want in any, what doesn't matter if it was stick built or CMU masonry, plumbing always stays away from exterior walls. So the plumbing wasn't as significant of an issue. But electrical, we all know, does have to go in those exterior walls. And what we were able to do is have them 3D print the openings for the boxes in those exterior walls. And we ran conduit into the cavity between the exterior portion that's printed and the interior portion that was printed. And we set that before we placed insulation. So now we have a chase that we could run wire. And the thought process is, one of the things that we could have done was possibly come with a UF or a different type of cable that would be more allowed in that situation, that could have reduced some cost, but it would also, going to Marion's, some of his points, it makes future maintenance a nightmare. So again, keeping in mind of thinking, thinking forward beyond the construction process, which a lot of construction companies have a tendency to only think of that construction process, and when it's done, the job's finished and it's done. Where this, we're thinking more longevity, long term. If we were living here, how would we, want certain things done? So.
Let me just ask a follow-up to that. So one thing Zach hit on earlier was the potential cost savings to consumers. And you mentioned insulation. Can you talk about, what kind of insulation is being used here? And maybe this is also for others on the panel, just, long-term, what are the benefits for the consumer if they are living in this home?
Yeah, well, ideally what we wanted to place in there was a closed cell foam spray insulation. But one of the primary ingredients in that insulation is imported from China, and it's no longer being imported into the country, and it's almost entirely unavailable. So we had to look at some alternative models and some alternative choices with this first house. But when we looked at some of these alternative models, which would be perlite or even rock wool, the energy efficiency, because the cavity is so large, really didn't drop significantly. One of the best things about this product, as far as the energy efficiency standpoint, is it's thermally broken, almost entirely thermally broken. There's only a few areas where we still do have some type of thermal intrusion in, and we even have solutions moving forward to be able to stop even those intrusions. And those are going to come at the door and the door and window jambs itself. Those are, but everything inside of the wall itself is completely open the entire way around. Now we have some metal wire reinforcement that goes between the interior layer and the exterior layer, but that allows continuous insulation. And as we all kind of know, the traditional stud construction, one of the issues is those breaks in the studs that allows a lot of thermal penetration into the building. By not having any studs basically in the wall or anything connecting the interior layer from the exterior layer, it allows us to have seamless insulation. A good way to think about that is on an existing structure, R13 insulation that you put in the walls is almost as efficient as 2-inch isolated 2-inch foam completely wrapped around the exterior. Now the R factors aren't the same by any means. The R factor of the R13 was what we typically would see inside of a wall, and the R factor of the insulated foam board, one would be a 13 and one would be 1 or a 2. But it's that continuous, seamless, thermally broken design that's realistically gaining a lot of our energy efficiency. A lot of people get hung up on R numbers, and we still do make an impressive R number. I believe our R value is 22, almost 23, but I believe it's 22.6 with the current insulation value. And so we found when we had to change the material, when we were looking at the different materials, that as far as the energy efficiency is concerned, there isn't a significant difference. And there won't be a significant difference because we are thermally isolated. And that's realistically the biggest key to its efficiency is stopping any thermal bridges. We do need good insulation and put good quality product in there that makes this even that much better of an idea. So when I talk about the Yeti cup, it's the exact same way. A Yeti cup is made of an inner shell with an outer shell, and the outer shell is basically spray foam insulation, and they sandwich the inner shell, and there's nothing connecting the inner shell to the outer shell except for that spray foam. It's the exact same concept with this house.
Zach, anything to add to that? And let me also just add on a question that just popped up about the anticipated building life. I know you've worked a lot with Virginia Tech to do some modeling. So anything to add about kind of benefit to the consumer, as well as just how long you think this structure will be there?
Yeah, in terms of how long the structure can be there, what we've seen so far out of Cobot and some other 3D printer manufacturers is they're saying 175 years. And that, as you know, and this is concrete, and this is really important, and especially when we talk to the inspectors and the zoning folks, that it's concrete. That's what we're using. The only difference between one of our homes and a stick-built home is our walls are made of concrete instead of wood. That's kind of it. Yes, we use a cool looking robot to print it, but it's still the same material. And so concrete's been around for 1,000 years. There's really no major issues there. Still a lot more to learn on that, though, of course. And but in terms of insulation, Stephen's right. I would echo everything he just said. One thing we are looking into are other greener solutions for insulation. I don't think we've landed on anything quite yet that we want to use, that we feel comfortable with, but we're looking into that now. And so hopefully next year there's going to be more options.
And kind of what other, oh, I'm sorry, go ahead.
I was just going to say, to echo some of what Zach was saying, we had the opportunity on this project to be able to build a wall and then completely destroy it. So we can all attest that the wall is physically strong. It took quite a few people pounding on it with the largest sledgehammer we can find to really do anything to it. We were all kind of set back. We almost expected it to break at a lower pressure because there's no because we have the wire reinforcement. It really strengthens a lot of stuff, but it stops that thermal bridging more significantly, and it was very, very strong. So
that was a particularly fun day, I will say that.
Why don't you just answer the question with forever?
Yeah, as long as you'll be around.
Yes.
It kind of, piggybacking on that too, Zach, when thinking about the future of this and looking at, the need for accessible housing, considerations around aging in place, have you thought about, building some of those attributes into future designs?
Absolutely. I mean, these homes are perfect for senior living and aging in place, especially because you can do zero entry. This is something that we're looking heavily into that right now. And there's been a couple questions I saw about, can you do condominiums? Can these be modular? Can you do townhomes? The answer is yes. The more conjoined these are, again, we believe that the cost will drop because we're not stopping the print. Of course, it's going to require larger printers, which are coming on the market. So we will be able to do that. But something else that we're looking into is this technology eliminates the need for basements. And really, folks use basements for two purposes, either for safety concerns from a structural standpoint or for extra space. Safety doesn't really need it at this point. It's a concrete house. But it's far less expensive to add 500 square feet onto a home than it is to excavate an entire basement. And that's really a big key for this moving forward. Of course, if folks want basements, can do basements. You can you put a slab and print directly on top of it. That's fine. You can do that, but it's far from cost effective.
Great. Certainly. We continue to hear about the need for more accessible units, and aging in place continues to be a hot topic. And I would just kind of add as an anecdote, as the father of 3 daughters, my basement is clearly for storage and not for my own personal items. I think we're, kind of, getting to the end of this and have been able to have a lot of lively, great discussion. I thought I'd just do one more roundabout with everyone, and then I'll start back with you, Zach. Just, any kind of closing thoughts or anything you want to share about benefits, challenges, future that you think would be good for our folks to hear?
I would say that there's very few states in the country that are tackling this concept right now. And it's kudos to you, Chris, Virginia Housing, Virginia Tech, everybody involved Virginia wants to be bold. I mean, Virginia is the #1 state for business in the country for a reason. And this is a big reason why. You're not afraid to take on these ideas and challenges and really be on the forefront of a lot of these new technologies. So we're very thankful to have formed this relationship and to continue to do this work together. There's only a couple of the states that are doing it. I wouldn't say they're anywhere close to being where Virginia is, especially this is something that's missed in the news, but this project, the Richmond home, is the first ever public-private partnership of a 3D home in America. It's the first one on the East Coast. These are really major accomplishments for the industry, and I see a really bright future for this going forward. So thank you for the opportunity to be with you today.
Well, thanks. And let me pose the same question to Stephen. Any final thoughts or any nuggets of wisdom or again, any other items you want to share with everyone?
Realistically, I've been excited to be a part of the entire team from what Virginia Housing has brought to bear, Alquist, Project Homes, Cromwell. I mean, everybody who's been involved in this project, just to be able to have that kind of that unique project to be able to do something that makes a real difference. I've been excited because of that fact primarily. It's been a great part to being a team member on this, learning and helping people all at the same time. Couldn't ask for a better project. I think that this is going to be the beginning. We're going to see 3D homes, structures, townhouses, everything as we move forward. And it's important that we invest in this kind of technology now. We could be on the forefront and really help a lot of people. So I've been happy to be a part of this. I want to thank everybody.
Well, certainly thank you, Stephen, and the whole team at RMT. You guys have been fantastic, jumping into a space that it's certainly experimental and we're all learning from. So really, do want to thank you and again, Warren and the rest of the team over there for getting on board with us. And that'll bring us back to Marion. Kind of any final thoughts?
Yeah, I would just echo what Stephen said. It's innovation is hard and it's complicated and it's expensive and it's risky, but everyone's dedication and patience with this process will definitely lead us somewhere. And that's really what it is. It's not about what is this thing right now. It's what could it be and what could it do for affordable housing construction in the future. So I'm excited. We learn a ton every time we do something like this. Sometimes it's stuff that we never would have thought of. You just got to do it.
Yeah, and thanks, Mary. All good points. Yeah, R&D and pilots and first time out. It's not going to always be easy and pretty, but certainly everyone on this team's been very dedicated to making it happen. And the exciting thing is, as Zach kind of alluded to, you're already seeing substantial gains in knowledge and savings just moving from one house to the next. And thinking about the application, this is not just for single family detached. There are attached options. It's can serve rental purposes, permanent supportive housing. All of those populations that we're out there trying to help on a daily basis. So I want to thank again all of our panelists and kick it back over to Erica and Flora if you want to wrap this up for us.
Yeah, I just want to let folks know that if you'd like to continue to learn more about this and to visit the 3D printed home in Williamsburg, mark your calendar for May 24th and 25th of next year, which will be the second Housing X conference that will be held out in Newport News. And 3D printing will be very much a big part of what is showcased, and we will continue to keep Virginia on the cutting edge of affordable housing innovation through all of these partnerships that we've developed. And, just like we were the leader in getting out that rent relief during COVID, it sounds like we're also going to be the leader in a lot of innovations in the construction world. So hope you join us for those future events and collaborations. Thank you all.